Dear viewers, welcome to our channel. Now I am going to discuss about a problem of CSIR NET December 2019 exams. This problem is related to nonlinear ordinary differential equations. Here we are given a system of nonlinear differential equation, and it is asked about the existence of closed path. So before going to further discussion, let us recall the Bendixon non-existence criterion. Suppose Bendixon non-existence criterion. Suppose D be a domain, D is a domain, and in the xy plane consider a autonomous system dx dt is equal to pxy and dy dt is equal to qxy, where p and q both are continuous function over this domain, and its first order partial derivative exists. If suppose del p, suppose that del p del x and plus del q del y has the same sign throughout the domain D, has the same sign throughout the domain D, then the Bendixon's non-existence criterion says that there exists no closed path. Now let us solve the problem. Here we have given p is equal to 4x cube into y square minus x to the power 5 y to the power 4, and q is equal to x to the power 4 y to the power 5 plus 2x square into y cube. Differentiating partially with respect to x, we have del p del x is equal to 12x square y square minus 5x to the power 4 y to the power 4, and del q del y is equal to 5x to the power 4 y to the power 4 plus 6x square y square. Now del p del x plus del q del y is equal to 12x square plus y square minus 5x to the power 4 y to the power 4 plus 5x to the power 4 y to the power 4 plus 6x square y square. This is equal to 18x square plus x square into y square. This is equal to 3 root 2 xy the whole square. Now we see that this is always greater than 0 and it never change its sign over the domain or over real number. Hence, by Bendixon's non-existence criterion, there does not exist any limit cycle or any closed path for the given system of nonlinear ordinary differential equations. Hence, option 4 is correct. Thank you for watching, and please do subscribe our channel for new updates. Thank you.